So, have you guys seen this equation? K equals A E negative E A over R T. Do you guys see that? No? Really? Do I even bother?
Is that big K or small K?
Say again?
Is that big K or small K?
The small K. He's never given you this. So if I doesn't give you this here, I don't want to like talk about it. Are you guys? If you can double check, that'd be nice. But this was at least on my quiz. Has he given you this one?
Maybe he'll show it today.
Maybe he'll show it today. I'll just go over it just in case. So you should know these two. I think he gives it to you, but even if he doesn't, okay. There's these two equations, right? This one is just saying, so EA is the activation energy, right? That's usually like it's in joules per mole, okay? Or just joules, like joules per mole or joules. Like it will most likely be in joules if you have that, okay? So activation energy would be like 10 joules. You plug that in there. Does that make sense? Okay. So activation energy will be like a unit. This is R 8.314, same as what you're used to. What you're calculating with this is the rate constant, and this is the temperature for that rate constant, and then you're calculating what the rate constant would be due to a change in temperature, right? Like all the time, like basically the higher you raise the temperature, the faster the rates will be, okay? And the higher the rate constant value, right? So if I change this, if this is like at 300 Kelvin, I'll have some rate constant, and I can figure out how much it would be at 500 Kelvin. I have some rate constant, but I have to be given the activation energy. Or you can be given both of these, and it says what is the activation energy. Does that make sense? So this one is more plug and chug, right? Does that make sense? Yeah. And then this one is kind of like plug and chug too, except A is like some just constant, like he'll give it to you. A equals 1 or A equals this. Does that make sense? He'll give you what A equals, okay? And one thing I saw he did on a quiz, like this will make more sense when, basically is like, this will make more sense when he goes over in lecture, hopefully. But this is little k, and then activation energy, temperature, R, and then some constant, okay? Now what is basically he'll give you like, this is the value of A. What is the rate constant if the activation energy is this at this temperature? Does that make sense? And just plug and chug there. Now one thing I've seen him do before is he'll give you a graph, and he'll say like, what's the activation energy? And it's like a line graph, and you're like, how do you do that? But you have to look at the axes, right? So let me show you something. Like I'm gonna just kind of make this a little nicer, right? So what if I natural log both sides? Okay, if I did that, I can separate these two. Okay, I can separate those two, right? I'm gonna switch these two real fast. So I'm gonna write out natural log K equals natural log E negative EA plus natural log A. Bring it over here. Does that make sense? Everybody see what I did? So again, if it's like this, right, I can bring the thing out to the front, right? The exponent. So I'm gonna just say natural log K equals negative EA over RT plus, or sorry, natural log E plus A. Does that make sense? Natural log E is equal to 1, right? Does that make sense? E to what power equals E? 1, E to the first. So then I could just rewrite this as ln K equals negative E a over rt, and then that was a 1, so we exclude it. So this should have been natural log a plus natural log a, right? I'm gonna just separate out the temperature. So I'm gonna write negative E A over R times 1 over T plus natural log A. Okay. Why did I do this? Hopefully, like, it'll make sense in a second. If you look at the format, it's kind of like y equals mx plus b. Okay, and if one thing he did last year is he drew it, and then the x-axis was 1 over temperature, not temperature, but 1 over temperature. Because if you did this with like temperature versus rate constant, no naturals or nothing, it'll look like a really funky graph. But if you do this, it'll look like a straight line. So then he'll do 1 over temperature, and this was natural log k, and it was a negative slope, I think, right? What is the y-intercept? Natural log a, right? B. Does that make sense? What is my slope equal to? Negative E A over R. So whatever the activation energy is equal to the slope. So if the slope, like for example, what he did is he gave you this graph, right? And he was like, he gave you this graph and gave you the slope, but he's like, what is the activation energy? And most people couldn't derive this, and they didn't think of this. They go like, okay, what the heck are these axes, right? They stop there. But if you know the derivation, you know that this is the slope. So then if I tell you the slope is like negative 8, then you say like negative 8 equals negative EA over R. R is 8.314. And then you get the activation energy.
So it'll give us the slope?
It'll give you the slope. Or he'll give you like the activation energy and he says find the slope.
Okay.
He'll give you one and you have to solve for the other. That's like the idea. Okay, and then like he can also give you stuff like
will it always be a negative slope, or is it just this problem?
it will always be a negative slope because of this.
Oh, okay.
Yeah. Yeah, and then like just make sure you know how to do yeah, basically the idea is like use this and that other equation I gave you that was like, oh, I already forgot it. It was like natural log K2 over K1, like we wrote it before. Sorry, okay. R. Oh, okay. This one? That one's plug and chug. This one is plug and chug. If they give you A, if they give you a graph, don't like freak out, just draw it out. So, like, practice this derivation in case he asks you like, derive this, something, or if he gives you a graph. Does that make sense? That is kinetics in a nutshell. So hopefully that helped. But go through practice problems on practice problems on practice problems, okay?
Thank you.
Yeah.
Thank you.